Hello everyone, I am Dr. Sayed Gupta and today I am going to try to explain to you a rather interesting topic, nucleophilic aromatic substitution, with the help of a story from history. And the story is the assassination of Julius Caesar. But first, let's look at what do you mean by nucleophilic aromatic substitution. You will have a nucleophile that will attack on a benzene ring, which is the aromatic center, and that will cause some type of substitution reaction. There will be a leaving group that will leave, and there will be an incoming nucleophile that will take its place. It's pretty simple. The problem is that nucleophiles are electron dense. Electron dense species, the main problem with them is that in an aromatic system, due to the excess of having 6 pi electrons, that incoming nucleophile with excess negative charge should be repelled. But how does this reaction take place? Let's go back to history. Let's remember the story of ancient Rome. In ancient Rome, we will consider Flurry to be the ancient Roman ruler, that is Caesar. The aromatic system over here, that will be considered to be ancient Rome, and the NO2 group over here will act as Marcus Brutus. How does the story proceed? The story will proceed where Caesar will have some type of an ideological difference with the Roman Senate. However, in chemistry, how will that be shown? That will be shown by me in a different way. The Roman Senate is over here, the incoming nucleophile. If you look over here, so over here, if you see, there is this fluorine group which can be classified as Caesar in ancient Rome. The Roman Senate is the OH minus or the incoming nucleophile. Now remember, like I told you before, nucleophilic aromatic substitution should not take place. It takes place due to under a special circumstance, because of a special group, that is the NO2 group. Now what happens over here? Just like in ancient Rome, what would happen is that the Senate attacks the weak spot of Caesar, and there leads to a total chaos of law and order in Rome because of the clash in ideologies between the Roman Senate, that is the incoming nucleophile, and Caesar, that is the fluid. Now, Caesar's close eye was Brutus. Now, Brutus is a very shrewd man. What he does over here is, over here, Brutus or the electron withdrawing group actually stabilizes this negative charge that is formed in the benzene ring. And you look over here, you see that this is how the benzene ring is now stabilized. Now, as the story goes, after the clash of conflict, there is a meeting between Caesar and the Roman Senate. Brutus was present, and during the meeting, Brutus goes on to backstab Caesar and kills him with a knife by backstabbing him from the back. Similarly, this electron withdrawing group NO2 acts as the same way. This over here, remember, Brutus backstabs Caesar so that the stability of Rome would be maintained. Over here, the NO2 group stabilizes the negative charge to ensure that aromaticity should be regained in the system. How does that proceed? The electrons are donated back to the ring, and the leaving group, that was Caesar, is kicked off. Kicking off of Caesar or removing of Caesar from its position reveals that Caesar is now banished from Rome, and the people of the Roman Senate has now captured the position. And however, you will see that at the end of the story, where Caesar is assassinated, over here fluorine is the living group that is left, that has been ejected from the system. The aromacity of the system has been regained, and therefore to maintain the stability of the system, this is kind of a forced elimination process in which you lose the living group, that is fluorine. The mechanism overall undergoes an addition followed by a elimination step. And thank you.